All right, hello everyone. We will get started in a couple minutes. I'm waiting for more people to join, but while everyone waits, I really appreciate if you guys would go down into the description and fill out the Google form that's for the signups, so we can kind of keep track of who's here and kind of get an idea of what's going on. Additionally, if you're not already following our Facebook, definitely go ahead and follow that group so you can keep informed on other events that are going on this year. We're going to be going on machine learning, SQL, GitHub, all those kind of things. So, and R as well. So definitely keep up with that. But yeah, we're about to get started here. Um, and yeah, so I will be running through this notebook, but if you want to run through it at the same time as me, you can go to our GitHub pages along the top bar, and you can download it from there or clone it, depending on how you want to do it. And yeah, and so yeah, any questions, feel free to type in the chat. I'll definitely try to do many stops and answer any questions. Um, yeah, so give it maybe 2 or 3 minutes, but then we'll start writing through the notebook. Hello? Sorry. Oh, sorry. Sorry. I did not realize I was muted. Um, all right. I'll go back and explain. But okay, let me answer the files in chat. I'm sorry. What file do we need to download? Student. Yeah. So if you go to our GitHub, there will be a folder called Python Workshop, and then we're in Python 1. So you can, if you download the entire Python Workshop directory, and then we're using the Python 1, which you can see up here, and then we're using, in students 1, you can code along, instructor has all the answers. So if you want to like say you missed it, you can go back and do it. Yeah, and so I will go back and now explain it. But can everyone hear me? Can I say someone in the chat tell me that I'm not muted before I move on to make sure? I'm assuming I'm muted. I see myself. Anyways, so what I was explaining here. Okay, so I'll go from the start. So basically, um, here we're importing the library pandas, which is like our data frame library, which basically is going to store all our data. This line, the pd.read.csv, is going to import our data, and since we have it downloaded locally, we can just type menu.csv. But we can also do like website links, those kind of things that store data. And then the head basically just gets the first um, couple rows. Um, and so, you can do like head of like 3 and just get the first 3, or you can do the head of 10, right, and get the first 10. And a lot of times you use head to make sure you pulled in your data correctly and that everything's working. Sometimes if you're working with like CSVs that are like formatted weird or like text files and you want to change it, there's a lot of actually like read CSV or like whatever like options you can do to make it do that. So a lot of times you just do like head, just to kind of see like making sure everything's in there and formatted properly. Okay, so next thing we did is while I was muted was that we used the whoops, the data dot column. So basically what that does is that it gets the name of each column and just prints it out for you. So and that's really it. So this gets you all the columns, right? So all 24. But then if you want to just get numerical values, so values that are basically like numbers only, you can do data.describe.columns, and that's one way to get numerical values. And the reason why is I figured I'd do data.describe. You can see here it gives a lot of like sample statistics. So like 260 like rows, the mean is 386, standard deviation 240, min max, and then the quartiles, 25th quartile, 50th quartile, 75th quartile max, those kind of things. And the reason being is that if you have, for example, a category, it can't really give the mean of a string, right? So if you do this and do dot columns, you will then just get the numerical. And then if you think about it, um, if you have all the columns and you have just numerical, to find the categorical columns, you can just subtract the two sets. And the set is basically an unordered collection of items. And it, like, say you have a set of A, B, C, and then you have a set of B, C. If you subtract the first one from the second, you'll just get the difference, or A, right? So what I did is you just get the set of all the columns minus the set of just the numerical columns. You subtract the two, you'll get just the categorical. And then I just cast this to a list from a set. Does anyone have any questions? I know I'm sorry about being muted, but yeah, I'm gonna move on. So basically, we kind of understand these ones are probably already gonna be fixed for us since they're numerical. But these ones, for example, serving size, item, and category. If you look at serving size, you can see like okay, like obviously it'd be pretty helpful to know like the grams or like the grams or like the ounces of it. But right now, like we can't really extract that because it's on a string, so we're probably gonna take that out. And yeah, any questions? I'll wait a second, but then I'll move on. Um, alrighty, 1 second, let me. Yeah, okay, so another thing we can do is that say we want to, you know, look at like, okay, so say for example in the category column, right? We want to take all the values, right? So if you look right here, we're only given breakfast, but obviously if you're in McDonald's, you know that they don't only serve breakfast food, they serve, like hamburgers, all that kind of stuff. So what if we want to see like all the unique values for that, right? So what you can do is you can do data, and then you do dot, and then you say the column, so category, and you can see here is that this will give you basically the column, and you can see here it starts at breakfast, and then it ends with protein and shakes, but it doesn't really matter. But what you can do is you can do the dot unique, and then this will do is we'll show you all the different categories. So there's breakfast, beef and pork, chicken and fish, salads, snacks and sides, desserts, beverages, coffee and tea, protein and shakes. So fortunately enough, we don't probably I mean, I don't know how, you could possibly, split this up in a certain way if you wanted to, but I think these are probably pretty good delineations. Um, yeah, one thing we can also check, here, let's move this maybe up here. Make sure. Well, but let's check this, right? So let's see like how many are in each category. Right, so like let's see how many are breakfast, how many are in this, right? So easy way you can do it is you can do data dot um, dot category dot count, I think. Oh, that's amount. That's not right. And you can say, and then okay, so then you can index it by saying where data dot category equals then brick, and then you dot count. So you can see, okay, so this is like one way you can do it, right? So this only gives you so you can see here there's 42 for breakfast, right? But what you can do is that we can put this in a for loop, right? So if so for so let's say category in, okay, so basically what we're gonna do is we want to loop through each category, right? And so what we can say is that let's call these food underscore categories. So we're storing this in the different categories, right? And then we're going to loop through it. So if you guys remember from last week, this is how we're going to do it. And what we're going to do is then we're going to go for each category. Instead of doing just a static breakfast, we're going to say category. And then we're going to do, so we'll do, then print statement, right? So we'll do print. And then we'll say something like category. Whoops, I forgot a colon. So, okay, here you go. You can see it now. So, you can see here that something like coffee and tea has like a lot, while something like breakfast, beef, pork, chicken are all like relatively the same. Snacks and sides. So like they're not something that's like 10 to 20 times more than anything else. And so that's probably a good reason also not to do it. You could also probably store this in a dictionary if you want as well. Yes, but okay. So does anyone not explain how I did this or why I'm doing this? Type in chat if you're confused. Or also give me a yes if you get it as well. But yeah, basically we're just making sure that like we shouldn't split these categories in half, or like these are like logical categories, right? So if like I don't know, maybe they had a category called like sandwiches, right? Obviously sandwiches can be like a McChicken or a Big Mac or I don't know stuff. You probably want to split it to like they did, right? And yeah. And yeah, so also what we can do is we can also, say we have this like nice little list here, right? But say we want to plot it, what we can do is we can do data.category dot count, or we can do dot unique. Well, I can just do dot plot maybe. Let me 1 second. Let me make sure that's how I do it. Sorry, 1 second. Let me think. So if you get this and you do dot unique. 1 second, guys. Sorry. Let me try to find it in here. Oh, sorry. Value count is how you have to do it. Dot unique. Okay, and let's type bar kind equal. There you go. All right, so you can either do a like a list like this, or you can do a plot. So sorry, I forgot the syntax. So basically, what you can do is you get the column, and then you do value count. Basically, does the same thing up here, and then you do plot, and then you say kind bar. So you can see here that obviously coffee and tea has the highest, and it kind of sorts down. So obviously, there's not many salads. Not that surprising. Okay, so one thing, so that column's kind of done, right? We're not going to be able to do much for that column, right? One thing we did notice, if you go back up here, is that this serving size, right, is not very useful, right? Because if you look at it, so let's see, we can show you, or I can show you, is if you do like type, which basically shows you the type of it, a type like, with like integer, float, this kind of things, of what's it called? Serving. What's the name of the variable? I already forget. It's with a space. Really? Yes. Sorry. Okay, so here's one thing, right? So since this has a space in it, you obviously can't do this, right? Because if you do this, it breaks. So what you have to do is you have to do this syntax. So this is another way you can call a column. Oops, not matching. This is not what I want to do. Basically, I'm trying to get. Let me go do this. Sorry guys, so 1 second. So basically what I'm trying to do is show you that this is a string. Here, I'll just show you. So if you do this, basically I'm trying to show you that this is a string. So since it's a return object, which you like, that's not a string. If you get like, like the first value, right? So 0, you can see that, this is type. Whoop. So you can see the string, right? So we need to fix this, right? So ideally, here, I'll leave this. Ideally, we'd like to take the important stuff out, right? So ideally, we'd like to probably get like everything to grams, right? Since fluid ounces, obviously you can't have fluid ounces of like a hamburger, but you can have grams of like a drink, right? So ideally, you'd want to get, the 136 out of it, right? And the same thing for the next byte, the 135, right? So what we're going to have to do is we're going to have to use those skills we learned last week about indexing, right? So yeah, and also, okay, so a good thing to do is that first we should see, make sure they're all in the same format, right? So say some don't have this G and some do, like in my custom issues, right? So let's do same thing, data, and then we have to use this syntax to get the column. Serving size dot unique. And let's just see, right? Is there any anomalies in this column? So just by glance, okay, so this is one doesn't have an ounce, but has a cookie, but still has grams, so we should be good in terms of getting grams. Okay, so here's an issue, right? So if it doesn't have grams, we're gonna have to probably convert the fluid ounces into grams by some conversion. I think they actually give it to us below. Yeah, so 1 fluid ounce is equal to 29.57 grams. So that shouldn't be an issue. We're about to do like a different type of conversion. And besides that, so basically everything's pretty good. We just have to convert from, basically extract this number from the grams, and we're going to have to, if it doesn't give us grams or milliliters, I think we're just going to assume that 1 milliliter equals 1 gram. Here, that we're going to get, then just convert this fluid ounces into grams. Does everyone get this? Alrighty, so in order to do this, we're going to first, so let me explain. So what we want to do, right, is we have, here, I'll just display it up here. You know, if we have data dot, currently we have this column, right, the calories, or the serving size column, right? Ideally, what we want to do is we want to create a new column from this column that maybe just like serving size in grams, excuse me. And it's just values, right, instead of the string. So what we want to do is we want to extract it, right? So what we want to do is for each row, we want to create some type of function that will read this value in, and then it's going to then return the number, right? So what that's called is like a lambda. If you're not familiar, lambda is basically just like a mini function that instead of you like writing like, you know, like this, like define whatever, you just basically like, it's almost like a throwaway. You create some, basically you can apply it to something else. Is the best way to say it. And so we're going to basically create our lambda function here, and then we're going to apply it to this row, right? If that makes sense. If it's not, please type in the chat. But the idea is, okay, first thing we want to do is we want to do the cases where they give us grams, right? So if we're going to say if, so we're going to say if, sorry, let me, 1 second. Let me, okay, whatever. So we're going to, so here, let's create a block code. So we're saying, let me take this example up here. So first thing we want to do is we want to find the index of our G, right? So I think we can use the dot find G, right? And that should give us, yeah, okay, sorry. Okay, so we want to find the case when there's a G in it, right? So we're going to say if this contains G, right? So if we do dot contains, sorry, let me go look at the solution guide really quick. Whoops, sorry. Sorry guys, 1 second. Okay, so they hard do it. They hard code it. I'm not a big fan of that solution. Oh, whatever, it's fine, I guess. It's basically what, okay, yeah. So basically they're saying if data point at, okay, so let's think about it. If this is -1, this is -2 equals G. So basically they're saying there's some gram in it, right? Right, that's what they're saying. Or beyond. So basically this is the case that if they give us grams, right? What we're gonna do is then Here, I think it might be better to copy and paste and explain instead of me trying to do it. I think because it would be just a lot sloppier. Okay, so here's the final function. I don't want to necessarily code it from scratch because then there might be inconsistencies between the instructor and student. But basically, the idea is that okay. Oh, okay, I just deleted two. Oops, sorry. Data serving. Okay, so basically the idea is that if they're checking at negative, the first thing they're going to do is, right, you get this data point, and you're going to check, okay, at -2, so -1, -2, is there a G, right? And so what that does, oh, is there a G, basically G, and then like a closing parenthesis. You could also probably just do this and this, but it doesn't matter. We'll leave it the way. Oops. Sorry. Um, and basically, okay, so basically they see if this can contain the G, right? Because remember there was some that didn't contain it. And then what we do is we find the point, or find the indice where it's basically the opening parenthesis, right? And then all we do is that we index it. We get the data point where it starts. So basically starting here, and then it goes until -3, which would be right here. So we just get the gram value. So the reason why we can't just do hard code is because, like, say if it's 2, this is going to change. Does everyone get this? Any questions, put in the chat. Appreciate that. But yeah, that's basically how that works. And the same concept happens for ML. And yeah, like we said, we convert 1-to-1 between milliliters and grams. So same concept, except we go one farther back because obviously ML is one more character, so we go one farther back in the same concept. All right, and the last one is for the fluid ounces case, which we saw like right here. So this one, all we're going to do is we're going to find the first space and then get all the values before that. So that's what we do. It says we find the space, the first. So basically, finds the first occurrence of this character, which in this case is space, and then so that gets the first value, and then we just get all the values before, and then we multiply it by our function, or by our conversion ratio, which we set up here, which was 29.57. So if we want to see it works, now what we can do is we can do check it, do serving size cleaning, and then we can put in our data, right? So data oops, serving size. Oops, I have to run this. All right, what's going on here? Oh, sorry. It doesn't. This won't take the entire column. We'll do that later. We're just gonna take like a single, like a single value. So for example, say we do like 12 fluid ounces, and then like 128 G. See, it'll return just the number, right? Which is really nice. So basically, this works on like one row at a time. But now let's do it to the entire column, right? So what we can see is that so we can do the apply with the lambda. So we do data dot or serving size dot apply. So we're going to apply our function, which is serving size cleaning. And we're going to probably do like a sample 10. Okay, so let me explain. So basically you get your column, and then the apply is basically taking, it goes row by row, and then converts the string into the float or numerical number based on the function we created here. So and then what sample does is that it basically randomly selects the entire row. So for example, if we just did this, it does the entire thing. And if we do sample, we get random. We can also do head. We can also check, like 136, 135. Let's check it. 136, 135. All right, so we're looking good, right? So now let's save it to our data set. So now we know it's good, right? The function's good and that it'll all work out. We can do data, and then let's call this, make a new function called like, let's maybe a G underscore serving size. And then we can just and then basically we can just do this. Copy this. And then now it should be in there. So if we do data dot head, let's do data dot columns, I guess. Whoops, did I not? Sorry, I don't know why it's not entering. Maybe like this. Sorry, sometimes this is a little tricky. This is a little funky the way they do it. Let me. There you go. Okay, so you can't use a dot. You have to use this method of calling columns. Basically, we create a new column, right? But yeah, there you go. So also you could replace it too, right? So you don't have to. So say we want to replace it. So say we don't need all this other stuff now. And then we do the serving, the serving size column. There you go. So now it's just numerical value, right? Then you can see here also it's a floating type, right? All right. One other thing I will show, which I don't think it's actually said in the instructor version, is the fact that you can actually drop. So if you do data.columns, whoops, need type. You see we accidentally I created this one, but now I don't need it because I actually just replaced all the stuff in serving size. What you can do is you can do data.drop, and then you say the name of the call. You can say you do this, and then you can name multiple. I'm just gonna name one, so G underscore serving underscore size. And then what you say is axis equal 1. And you might be confused about what the axis means. Basically what this is saying is that if you say 1, it's basically saying you're going to drop columns. And if you said 0, you're going to drop rows. So we want to drop the entire column. And we want to drop the column name G serving size. So you run this, it will return the data frame, but you need to store it. They dropped like this. So now, if we go and check data again, we can see that it's gone, right? So yeah, if you ever, sometimes you create something, you want to drop it, you don't have to go back all the way up to the top and re-import the data set in your notebook. You can just drop it, and it should work. And yeah, that's kind of, so we've cleaned up kind of this function, or cleaned up the serving size column. And I guess now let's kind of explain like what lambdas are. So since basically we just created one, say for example, we create the lambda. Okay, yeah, so this lambda where you input the value of x and we return x squared, right? Let's see what they're doing actually, because I don't want to be. Okay, yeah. So basically they assign it to say a square. So basically you're creating like a tiny function, right? That you can then apply to other stuff. So you create a square function, and then you call square of 5. Yep, and then that works, right? So basically lambdas, I'll read it out, but in Python there are functions that allow us to create temporary small functions. They're very helpful in transforming data in lists or data frames using the same apply function we use. Therefore, we don't have to make complete functions for small attacks. And yeah, that's basically kind of lambdas are. We can also do 2 parameter ones. So we had like addition, where we have lambda x comma y, or maybe x plus y. Then we have addition 2, 3. Yep, so that's kind of how I do it. Alright, and so, yeah, so that's kind of a lambda nutshell. And now let's create a lambda function that we can then apply to our serving size that rounds it. So basically the idea is that, let's just pull us like data dot, or let's do the serving size. You can see here that they're all decimals. Now I don't necessarily know that if they're going to be all 0.0. It looks like they are, but let's just for thoroughness sake, let's create a lambda function that will round, right? So let's call it round. Where basically the idea is that you're going to, given some lambda, you're going to given some like input, let's call it, or x. You want to then return x dot, I think it's dot round, and to 2 decimal places, I believe is correct syntax. Let me make sure. Oh, sorry, you do like the wrong syntax. Sorry, it's round x2. So basically, what this does is it's going to allow us to round a decimal down to 2 decimals. So for example, if you do round, let's say 1, 12, 3, 4, 5, 6. Oh, sorry, this is not. So the reason why this is erroring is because round, as you can see here, is like innate to Python. And then if you try name it over top, it'll be confused. So let's just round 2, for example, just for writing 2 decimal places. Oh, why is this erroring? Okay, let's not use this one. Let's do np dot. Here, okay, let's import another library. Import as np. That's np dot round x. There you go. Sorry, so I don't know why the normal round function was working, but yeah. So basically, NumPy is just another library that's used in data science. And yeah, basically just takes the first 2 decimals and rounds it, as you can see. So now, so now let's apply that to our serving size. So data serving size equals data serving size. And then we do our dot apply, and then we can do our round underscore 2, right? And so that will do it, right? Also, you don't have to necessarily declare it, like create a separate lambda each time. What most time what you'll do, if it's in such a small function, you can actually just do this as well. So sometimes, probably a good workflow idea is to, maybe like code it really quickly in this, make sure it works, and then you can just put it there. It kind of cleans up your code. But yeah, so we'll do this, and now everything should be rounded to 2 decimal points if it wasn't already. Anyone have any questions? I'm gonna stop for like a minute or two, drink of water. Anyone have any questions in chat? Either about code or like workflow wise, or any questions? I'm gonna wait probably a minute before I move on. But now we're gonna go into like exploratory data analysis. All right, so I'll move on. All right, so now that our data is like a relatively better spot, we've basically, and this as it's probably simplified, but we've cleaned up the serving size column. Now let's start seeing what's up, right? What's going on with their data, right? So probably I think the most intuitive way to visualize, or not visualize, but understand data is probably graphs. Looking at long streams of number usually isn't that informative, and graphs for at least humans or maybe just me is that looking at a graph. So best way is to use this library called matplotlib, which basically it's a plotting library in Python. So if you use MATLAB before, this should be very familiar syntax, and if not, it's pretty straightforward as well. So yeah, let's import matplotlib.pyplot as plt. And this is just kind of convention. Don't ask why plt. Well, it's because, py plot or plot, whatever you want to read, but it's just basically the .pyplot is the one we're going to use. So yeah, so the first question we're going to ask is, what's the breakdown of the categories of food in the menu item, right? So we've already done this, so let's just do it really quickly. So it'll be data.categories, categories dot value underscore counts dot plot, and we'll call this the kind we want it to be bar. Did I spell that wrong? Data. Oh, it's just category. Whoops. Let's delete this. Yeah, so it's kind of what we had before. We can also do is we can do like I think it's called like horizontal plot. No, never mind, it's not. Wait, I think it is though. Let's see. It was bar H, I believe. There you go. So this is a horizontal plot. Um, yeah, so it's like basically but we can also what we can do is we can make like a pie chart. I would never really recommend using a pie chart, but just for like fun sake, we can then see kind of a pie chart so you can get ideas that you can see majority of it's coffee and tea, and that's probably for the McCafe options, right? So if you you can do like sugar, no sugar, milk, no milk, light milk, whatever. Let's look at that. So data dot category. I can't spell. And then we'll basically index it. So we're gonna say we're data dot category equals cough and tea. Whoops, I don't want this. And then okay, so then we'll do dot item. All right, so here, okay, so let's do dot unique. Okay, so basically, okay, what I did here is I got all the data. Whoops. And then I basically index this, the check. I only want the categories, that's coffee and tea. And then I get the names of it by doing the item, and then I get the unique value. So as you can see here, the reason why there's so many values, or like this portion so big is because like, okay, yeah, so it's like, these three are all the same, but it's different sizes, right? But it's obviously all different calorie counts, those kind of things. Also, there's like child. Okay, so yeah, and you kind of see that what I was talking about before. It's like sugar free, and then there's like hazelnut, all this kind of stuff that makes it, this category big. And probably reality, it's probably one of the smaller categories. But yeah, that's kind of an interesting topic. So maybe when you're, maybe if you want to maybe consolidate these all into one, and forget about size, maybe just take the medium one from each, um, stuff like that. So yeah. Okay, so now let's see. Okay, so another question is like, which of these categories have the most and least categories, or most and least, um, calories, right? So we want to get the max, basically the max and min in each column, a max and min, right? So let me just make sure I'm gonna do it the way they want me to do it. Okay, so first thing we want to do is we want to get all different categories, right? So we want to do, I think I already have this. Categories equal data dot category dot unique print category. Oops. Okay, so basically it gets all the categories, and what we want to do is we want to go through each category and basically get the max and min, right? So let's just do one example, then we'll make it into for loops. So let's say data dot category, or let's do data, and then where the data dot category, equals. Let's just start with the first one. Let's do maybe salads, and let's get the calories. I think no such attribute as calories. All right. Well, let's see how did I spell it wrong? Uh, capital C it looks like. Yeah. So okay. So yep. So we get we get all of basically the calories for this one, and then we want to basically find. Let's just call this, I guess, for a minute. Let me call this temp for the time being. And let's say we can print now uh, the max of temp, and we can well let's do this. And we can probably do the same for min, right? All right, so we can see for salads the max is 140, the max is 450, and min is 140. So, but now we want to do this for each column, right? We want to probably want to source in dictionary. Um, sorry. Yeah, so how the most, which is categorized the most in these categories. Okay, so also let's also do okay, yeah. So now let's up. I think in this one they do the mean, but let's create let's create two um let's basically create two dictionaries, one for the max, one for the min, instead of doing the mean. So okay, let's do a for loop like before to loop through each category. So for cat and categories, we want to say the max val equals max. And we probably want to replace this with cat. And you probably want to, do the same thing, but min.